Hello learner, welcome once again to Manifested e-learning platform. We are going to continue or proceed with our lesson on similarity and enlargement. In our today's lesson, we are going to dwell on similarity in composite triangles. Similarity in composite triangles. So the objective of the lesson is to enable the learner to calculate some missing sides whenever he's given a question involving the composite triangles. So a question will come, which is this composite triangle? It is a triangle from which you can get at least two or more triangles that can be similar, and there are some properties we shall see that make those triangles to be similar. So we shall go straight to an example. So that is a composite triangle on the board. I call it composite because, so one would ask, why is it composite? In that triangle, we can get two triangles. So to come to that, I can only explain that if I can give it vertices. A, B, C, D, E. So learner, those are the vertices I've given it. So we realize I can get two triangles in the name of A, B, C, and A, D, E. So from the triangles, we said the angles in a triangles are the ones that make them to be similar. If the corresponding angles are equal, the triangles will be similar. So let's come here. The two lines DE and BC are what? BC and line BC and DE are parallel. That is what we know. So when a two parallel lines are crossed by transversal, by a line, there is a series of corresponding angles created. You'll find this angle will be equal to this one. So you realize angle CBA will be equal to angle EDA. We call them corresponding angles. They are corresponding angles. So you'll get two pairs. This is one pair. This is one pair, and that is the other pair. So you also realize BCA is equal to DEA. And the angles I'm talking about, they are actually angles in the first triangle, A, B, C, and angle A, D, E. So you realize two pairs of the triangles are equal. So it means this common angle, this is a common angle to both the triangles. So you say angle BAC is common to the two triangles ABC and ADE. It is common. That has shown that this angle, since it is common to this triangle and that triangle, the two triangles are similar. So the two because the corresponding angles are equal. So having proven that, because this angle corresponds to that, this angle corresponds to that, this angle is common to both of them. So it shows these two triangles are similar. So I'll go to what we call the corresponding sides. So it will mean, therefore, we can write therefore, BC divided by its corresponding side in the other over DE, BC over DE should be equal to AC over AE, AC over AE. So you'll go, do I know BC? Yes, you substitute. So 16, DE is Y, the length I was supposed to calculate, should be equal to AC. AC is 9 plus 3. 9 plus 3 divided by AE, which is 9. So you'll come and say 16 divided by Y is equal to 12 over 9. You cross multiply, 12Y is equal to 16 times 9. So Y will be equal to 16 times 9 divided by 12. You divide by 12. So you simplify, 3 goes there, 3 goes there, 4 goes there, 1, 4 goes there, 4. So Y will be equal to 4 times 3, 12 centimeters. So you check the working and why we came about with that similarity. That similarity came from the two corresponding, the angles in the two triangles being corresponding. And why did we call it composite? Because in that figure, which looks like a triangle, we get two similar triangles created by these two parallel lines. So we shall look at another example. Example B. So we still have the second example where we still have the composite. It is a composite triangle. You can give it vertices A, B, C, D, E. So in that, they tell you find the value of x. Find the value of x. So you find the value of x. So in that first example, we said when two parallel lines are crossed by a transversal or a line, they create a series of pairs of corresponding angles. The corresponding angles happen to be the angles in the two triangles in question. Like this one, you'll find this angle is equal to this one. that angle is equal to that one, proven in the first example. And this is a common angle common to both of them. So we shall come and look at what we've been given. So by similarity, so when I say similarity, I want to go to the ratios of the corresponding side. So by similarity, AB divided by ACD, the smaller triangle, this base side of the larger triangle divided by the base side of the smaller triangle should be equal, I'll come to this side, should be equal to AE, which is a side of the longer, the bigger triangle, divided by AE, divided by what? Divided by AC, divided by should be AE divided by CE. So we shall first of all get CE. Once we get CE, we shall subtract from 20 to get X. So we shall move from there. AB, learner, it is 10. So it will be 10 divided by CD, 7, should give us AE, 20, divided by CE, which we don't know. We can get this one. After getting CE, we shall get X. So it's just write CE. So on working that, you cross multiply. 10 times CE is equal to 7 times 20. Is 7 times 20. Therefore, CE, divide 10 on both sides, will be 7 times 20 divided by 10. So CE is 14 centimeters. So CE is 14 centimeters. So you'll come and say, but X, they have asked you for X, but X is equal to 20, subtract CE. But I've already got CE, isn't it? So it will be 20, these are centimeters, it will be 20 centimeters, subtract 14 centimeters. Therefore, my X will be equal to 6 centimeters. So that is how we use similarity to work out questions involving composite triangles. So in most of the composite triangles, you'll find parallel lines. The parallel lines are the ones going to give you those pairs of corresponding angles that will make those two or more triangles in there that's similar. So they can even be more. If I put there another parallel line, we shall get 3 similar triangles. Another one, we shall get 4. So they can be many. They can be as many as 10 or even more, depending on these parallel lines within the triangle. So having objectively met that, we've solved questions. We've solved 2 examples on composite triangles. It will be time for us to work out an assignment to accomplish that objective. So shall create space for the So the assignment will come from Mathematics for Kenya Schools by Patel. That is exercise 7.1, number 16 to number 19. So the learners not not knowing the book. This is the book where you'll get that assignment for this lesson. So at that juncture, I wish to close the lesson, and I hope in the next lesson you would have gone through those solutions for us to easily proceed to the next lesson. So thank you, Lana, for the audience, and have a nice time, and let's meet in the next lesson. So bye-bye.